Okay, here's your second video to the 3-2-3-3 notes on solving inequalities. So we just discussed why this rule exists, why you must flip the sign if you multiply or divide by a negative. Let's do some problems. Now I know these are simple, guys, but please watch the details. You don't want to lose your negative sign, okay? When you look at this first one, you only flip the sign if you divide or multiply by a negative, okay? I don't care if there's negative over here. When I'm solving, if I need to divide or multiply by a negative, I now know I need to flip the sign. I would write that sign down first so that you don't forget. Then these cancel on the left, and you have x is less than negative 27 divided by negative 30 will be a positive 9. X is less than 9. You only need 3 numbers on your number line. I'm not including 9, and I'm going to the negatives. Your next equation, take a look. You have 2/3 r is less than negative 9. In order to get in order to get r by itself, we want to get rid of that 2/3. You might write down that you're going to divide by 2/3, but remember, dividing by 2/3 is the same as multiplying by 3/2. And this is a little bit neater for your work. The 2's cancel, the 3's cancel, you're left with r. Did I multiply by a negative number? No. So you don't need to flip the sign here. We'd have negative 27 over 2. And you can write that as a decimal if you want as well, negative 13.5, 13.5. Remember, when you're doing your negative numbers, negative 13, negative 13.5. You can do half steps if you want, negative 14, negative 14.5. Notice the larger digit is heading towards the left, right? Those are more negative numbers. So we're going to have negative 13.5 open, shading to the left. Last example, take a look. What do you need to do to get x by itself? We divide by negative 8. Oh, right there. You should be saying, wait, let me flip the sign, and then I'll keep working. Dividing by a negative flips the sign, and we have 72 divided by negative 8. We get a negative 9. Again, watch how you number your number line. Negative 10, negative 9, negative 8. We're going to include negative 9 this time, and it's greater than that number, so we're heading towards the positives. Okay? To pause the video to show a quick check step for each one of these, and then we'll move on to the next one. Two more here. Remember, we can solve using decimal, or we can solve problems involving decimals too. Don't get scared. So I would divide both sides by negative 0.25. Dividing by a negative, again, flip that sign immediately. When you think about this, you should be able to do this without a calculator. If you think about, okay, this is like a quarter. How many quarters do I have in $4? Well, I have 4 quarters in each dollar. So on $4, I have 4 times 4, I have 16 quarters. Plus this leftover 25. So you would have 17 quarters. It's a positive divided by a negative. You would have a negative 17. If it helps, you could also make this a fraction. We could say this is 4 1/4. Oops, that's not a 4. This is 4 1/4. And you're dividing by 1/4. 4 1/4 is 17/4 times, keep switch flip, 4 over 1, and you can see the 4's cancel. So either way, you're going to get the 17. A positive divided by a negative makes a negative. Turn your answer around then. H is greater than or equal to negative 17. It doesn't ask us to graph here. We just need to check our solution. So a quick check step. What is an easy solution that's greater than 17, negative 17? I would do 0 or 1. It's just easier. If I do 0, negative 25 hundredths times 0 would be just 0. Is 0 a larger number? I'm sorry, is 0 a smaller number than 4 and 25 hundredths? It is, so it does check out. Of course, we love the word problems, so one more of those. Ryan has a $20 gift card to an art supply store where 4-ounce tubes of paint are $4.30 each after tax. What are the possible number of tubes that Ryan can buy? So I want to know the possible number of tubes that he can buy. What's some important information here? He has $20. Each paint is $4.30 each. Since we have the word each, we know we're going to have a cost per item. That's going to signify us to multiply. So identify your variable. I'm going to do T for the number of tubes. And hopefully you already set up 4 3/10 x, or I'm sorry, 4 3/10 t is less than or equal to 20. He can spend all of his money, but he has to stay beneath that. Divide by 4.3. Don't be scared with these operations, guys, with decimals. You need to get used to it. I'm going to pull this over on the side. Remember, if you don't want to divide by 4.3, you move the decimal over 1 to get a positive integer. Add one more decimal point here, so you have 200. So then you have 43 into 200. That fits in 4 times. It's 172. You have a remainder of 28. Pull down to 0. How many times does 43 fit into 280? 6 times. My decimal point was right there, so I pull it up, and I have 258. We can stop at that point. Hold on one second. We can stop at that point because we can't buy part of a tube. So if T is going to be less than or equal to 4.6 something,
Mr. Lindner, please call 3000.
T must be less than or equal to 4. We can't buy part of a tube. And you could add something else on the other side. We're going to stay underneath 4. And just like our other example, we're going to stay above and including 0. So if you wanted, you can include this part. This is something that we're going to get to later in the chapter. But if you are comfortable with it now, go ahead and add it on. Your graph should, again, just be these whole numbers, these integers. All right, there's a couple more challenge and extend problems. Give it a shot on these, see if you can come up with something. For the last one, for 69, you actually are, on your note guide, you already graphed it on the warm-up. All right, good luck with your exit ticket.